Hello students, this is Professor Chalai, and in this video we're going to wrap up our discussion on different types of concentration units by talking about parts per million or ppm and parts per billion or ppb. By the end of this video, you should be able to perform various calculations using ppm and ppb. As always, you can follow along with our chapter 3 workbook. Now, just to bring you back to a couple of videos ago when we talked about percent weight by weight, which we mentioned was the mass of the solute, doesn't matter the units, mass divided by the mass of solution, again, doesn't matter the units as long as they cancel out, times 100%. And so we use this for different types of concentrations where, the percentage of the total solution is a reasonable number. However, in some cases, the concentration is so small, for example, you might have a mass percentage of 0.0000001%. That's a way too small of a number to express as a percent. So you might be thinking, well, is there a more efficient way to express a concentration that's this small? And you might also be wondering, well, what types of concentrations are this small? Usually these will be used to describe various types of toxins where the smallest trace can affect organisms. We would want to express very, very tiny concentrations. So how can we go about expressing concentrations that are very, very small? Well, remember what we talked about what the percentage means? Percentage just means divided by 100. We can go about expressing the mass of solute over mass of solution in other units other than just percentage, other than just dividing by 100. In fact, we can express it dividing by 1 million. So that's 1,000,000,000, or that's the same as 10 to the 6th. And we can express it as a ratio over 1 billion. So that's 9 zeros, which is the same as 10 to the 9. And so if we would write this out, we would have mass of solute over mass of solution times, let's do the million one, 10 to the 6. And since this would be divided over 1 million parts, we'll call it parts per million. And similarly, for the one where we describe our concentration over parts, over a million parts, we'll call this a billion parts, sorry. We call this parts per billion, which will be defined as the mass of solute over the mass of solution times 10 to the 9. So these are kind of like percent weight by weight or percent mass percentage, except instead of a percent, we're using a factor of a million and a factor of a billion. And this will allow us to describe very, very tiny concentration of things. But remember, they're all going to be masses of solute divided by mass of solution. Okay, so let's look at a couple of examples of these. Let's look at number 39 and number 40. And if you think you can do them, pause the video and try them on your own, and then unpause and we'll go over them together. Okay, like I mentioned, parts per million and parts per billion are often used to describe very, very tiny concentrations of things that can be toxic. For example, lead, a very, very tiny percentage, in fact, 15 parts per billion, can be considered dangerous. So let's say you have a glass of water that's 300 mils at this 15 parts per billion. The question is asking us, at that concentration, what's the mass of lead in your glass of water? Okay, so let's look at this question. They give us the volume of water and they give us the concentration. We know that the parts per billion should be mass of solute, which is what we're asked to find. What's the mass of lead? Remember, the units here are micrograms. We'll come back to that. We need the mass of solution, and this is parts per billion, so it's times 10 to the 9. So this is our starting point. We need the mass of solution. We don't have that. We have the mass of water. Sorry, we have the volume of water, but we should know that the density of water is about 1 grams per milliliter. So we can use that to convert our volume to mass, and by doing that we'll find out, we'll see that we have about 300 grams of water, which is our solution. So let's use that in our calculations. Let's work down here. So we have 15 parts per billion is equal to the mass of lead divided by our mass of water, which is 300 grams, times 10 to the 9. We're solving for the mass of lead. So the mass of lead should be equal to 15 ppb divided by 10 to the 9th power times 300 grams. You plug all of that into your calculator and you should get a number of about 4.5 by 10 to the minus 6 grams. However, if we look back at our question, we see that the question is asking us for the answer in micrograms, and we know that 1 microgram is 10 to the minus 6 grams. So 10 to the minus 6 here means we can just write this as 4.5 micrograms. If you wanted to see the conversion of that, 4.5 by 10 to the minus 6 grams times 10 to the minus 6 grams is 1 microgram. So the grams cancel out, the 10 to the 6 minus 6 cancel out, and we get 4.5 micrograms. So that's our answer for this question. A couple of steps that we needed to do was first convert the volume of water to the mass of water using the density of water, which is just 1 grams per milliliter. And then we use the mass of the water and the concentration here to figure out the mass of lead and then convert that to the appropriate units. Oh, by the way, this answer should have one significant figure, so that's about 5 micrograms of lead to 1 sig fig. Okay, let's look at number 40. Here we have a 50-gram sample of industrial wastewater, that's our solution, and it has 0.48 milligrams of mercury. Mercury here is our solute. Let's express this concentration in terms of parts per million and parts per billion. So let's do parts per million first. Parts per million is the mass of our solute, 0.48 milligrams, divided by our mass of solution, 50.0 grams. But again, this won't cancel out nicely, so let's just make sure that they do cancel out nicely by converting milligrams to grams. And then it's parts per million, so it's 10 to the 6th power. Plug all of this into your calculator, and you will get 9.6 to 2 significant figures parts per million. Let's do the same for parts per billion. 0.48 milligrams of solute over 50.0 grams of solvent. Convert this to the same units so that they can cancel out. And it's parts per billion, so it's 10 multiplied by 10 to the 9. Plug these in your calculator and you should get 9600 parts per billion. Remember, parts per billion, it will be 1,000 times larger than parts per million, so we didn't necessarily have to do all this calculation. We could have figured it out from parts per million. All right, so that will bring us to our various different solution concentration units. Just to let's go back to our notes up here, where the various different concentration units are just some measurement of the amount of solute over the amount of solution. The one that we'll use the most in this course is going to be molarity, where the amount of solute is in moles, the amount of solution is in liters. But we also did percent mass, where both of the solute and solutions are expressed as a mass. We did percent volume, where the solute and the solution are both expressed in terms of volume. We just look at other units, such as parts per billion and parts per million, where instead of multiplying by 100%, we multiply by 10 to the 6th for parts per million and 10 to the 9th for parts per billion. All right, this will bring us to the end of chapter 3. In the next video, we're going to begin chapter 4. I'll see you then. Bye.